Go, rock and roll. So first thing we want to do is to put our steps in order. What do you think step one? I would agree. Okay, we're going to roast and crush the beans. All right, then what might we do? Mix in the dry ingredients, temper it, and then package it. I agree. Okay, so let's see if we can kind of list what the inputs and the outputs would be in each one. So what do we have to start with? What ingredient do we start with? We start with the beans. So we put those in, and then that crushes them, right? So they crushed them first. And then after we have the crushed beans, it spits out. We put in the crushed beans, and it would spit out that paste. Okay. And then they add in all the other ingredients. That leads me to some chocolate. And then the last thing they would do would package it. It's what we see when we purchase it. Oh, stop that. It would actually be our lint that we purchase. Okay? So just kind of thinking about what we would do each time. So what happens to the output of each step? What happens to it for the next step? It becomes the input, all right? So we input the beans, the output, we crush them, then that becomes my input, the output is the paste, and so on and so forth, which is what we refer to as something is composite, all right? It's a composite function. We take one thing, we put it in, it gives us something else, we plug it back in to what we're doing. So now let's talk about math. All right, so we're going to think about the assembly line approach to analyze a complex function. So let's look at this function. We've got y equals the sine of x squared minus 3, okay? So the raw material was our input or our independent variable. What would be the independent variable of this function? What did we input into this function? Yeah, x, okay? We input an x. And so, I know, tricky, right? Okay, interesting. So you solved it, set it equal to 0, and solved. Okay, well, at least you were doing something, right? We got to start somewhere, okay? Now, all that to say, when we think about a composition function, all right, what would you describe as the inside function in that function? What would be the inside? Yep, x squared minus 3 would be our inside function. So that what would be our outside function? Sine x. Oh, helps if you point to the actual thing. All right, it would be outside. And we know when we do a composition, all right, f of g of x, all right, that would make g of x, x squared minus 3, and f of x, sine of x. Okay, so remember when we decompose functions, I told that really bad joke. What's Beethoven busy doing? Decomposing. But okay. My husband told a really good bad joke this week. Hold on a minute, I'll find it. Yeah, well, it goes in our family group chat, so it's easy to find. It's kind of it's a weird thing we do.
Jeez, what happened?
Okay, hold on a minute.
I have to wait for 1 second.
There it is. I dropped a copy of A Tale of Two Cities on my toe. It hurt like the dickens. Okay. A Tale of Two Cities is the only book from high school that I did not read. I'm not a Charles Dickens fan. So I read that Cliff's Notes, which is what we had to read back in the day. Anyway, confession's good for the soul. All right, so I always like to get that off my chest that it was the one book I did in high school. I cheated my way through that book. It's okay. All right. Just being honest. All right. But I do love to read now. If you like World War II, like if you like this, so we just read a book called Beneath the Scarlet Sky. It's long, but it's so good. And it's based on this guy, his true story, and about World War II in Italy, which is a lot that I didn't know about Italy. The only thing I really knew is that was where my granddad served in World War II, was in Italy. So he was there when the Americans liberated Italy and all that stuff. And he saw when they hung Mussolini upside down in the public square with his mistress and all that. So I can remember him telling me all about that. It's very true to his story, what is shared in this book. So, but this guy's story is just amazing. Anyway, so if you like World War II history, you might like that book. Anyway, okay, that's one of the books I read this week. I also read the third in the Children of Blood and Bone series. Not as good as it should be. She did not spend enough time. And then I read The People You Meet on Vacation. Complete fluff. Okay, but they're going to make a Netflix movie out of it. So it's a rom-com kind of thing. All right. Sometimes I have to cleanse my palate, read something really fluff, and then I go in and read something more detailed. And after I read too much fantasy, I have to stop and just go read something complete fluff and clear my palate and then come back. That's why I struggle with all the Throne of Glass. Like, I just couldn't get through it. It was too much. Like, I got overwhelmed and I had to stop. Okay, anyway. All right. Okay. Sorry. We're getting ready to read a book about Alzheimer's. It's going to make me cry. All right, so let's look at this one. So now it says, imagine evaluating this function x equals 5. What happens first in the assembly line? What would be the first thing we would do? Yeah, we would plug in 5 for x. So we would square 5. We would subtract 3. So we would start on the inside, which would give me what 25 minus 3 is 22. And then the final step would be to take the sine of 22. And that's just basic composition. We've been doing that for a long time, okay? But now let's consider it in terms of derivatives. So it says, to find the derivative of this function, we'll need to consider how each link in the chain, how each step in the input and output contributes to the end product. So what they do is they're going to label that inside as a block, okay, that black box as x squared minus 3. What would be the derivative with respect to x of just that black box? So of just x squared minus 3, what would it give me? It would be equal to x. Okay, all right. So if we plugging back into our original function, we see now that y is equal to the sine of the black box, okay? But I want to take the derivative with respect to the black box of sine of the black box. So what would be the derivative of sine? It would be cosine, okay? Cosine of the black box. But then what did we say black box was defined as? No. X squared minus 3. Okay, so the black box is defined as x squared minus 3. So this is really cosine of x squared minus 3. So then how could we use our parts A and B to get our end product, which is dy dx? So the two pieces that we found were the derivative of the black box with respect to x and the derivative with respect to y of the black box. And I got to find a way to use those to get dy dx. What would I have to do with those two derivatives? Okay, how could I use these first two to leave me with just dy dx? Think fractions. Fraction arithmetic. Yeah, well, we don't have to go that far. How would I use those first two fractions that I've got written there to produce just dy and dx? What would I have to do with them? Multiply them, okay? I would just have to multiply them, right? Because what would happen to the derivative of the d black box if I multiplied those two fractions? They cancel out, right? Because one's in the numerator, one's in the denominator, okay? And so this is what the chain rule says to us now. So if we think about what we just did, okay, so dy dx would equal d black box dx was 2x times, and the other one was cosine of x squared minus 3. Now, how do we put all that together, okay? That is the chain rule, right? It's a composite function. And so to find the derivative of any composite function, So we have y equals f of g of x. And so if we think about what we just did, f is our outside. Okay, g is our inside, or what we term that black box. Okay, so that inside function, right? And the chain rule is how we find the derivative of compositions. Okay, it's a product, right? So we just said that dy dx would equal the derivative of the inside with respect to x times the derivative of the outside with respect to the inside. Another way to think about it, okay? Y prime equals derivative of the inside, stop that, times derivative of the outside evaluated at the inside. Okay, so two different ways to look at that. So I like to write it in words. So chain rule, derivative of the inside times derivative of the outside evaluated at the inside. Okay, I think you're going to see why here in just a few minutes when we start working with some of these, why we spend so much time looking at them. Okay, because so many things come out as a composite function versus something else. All right, so let's do a little flashback. Let's decompose some functions. So h of x equals, start with our warm-up, x squared plus 1 squared. What was my inside? X squared plus 1 is inside. What am I doing to the inside? I'm squaring it. It is something squared, so we just call that something x. Okay. One more, this one's for you. Okay, just throw a square root in there because you like those. Okay, all right. All right, so we have to be able to identify a composite function. All right, what would be the inside function for that one? X plus 2. What are we doing to that x plus 2? We're taking the square root, so it would be the square root of x. That would be my outside, okay? So identifying that inside and outside, okay? So let's take a look at some functions, all right? Let's decide if they are compositions. If they are, then let's determine what is the inside and what's the outside, okay? What's my G, what's my F, all right? Not all of them will be, right? But let's just look at a few and see. All right. All right. rock and roll. Take a second and look at those 6 functions. All right? Which ones are compositions and which ones are not? Is that your bag?
Yeah.
When you're old like me, you'll be like, oh, I can't move. Oh my gosh. You're a robot. This is a short unit. Yeah. Yeah, unit 6 is a bad one. No. It's a matter of opinion. I don't know. It's hard to tell. I like how they spread the curriculum out because they put bad stuff in every section, so you never just get all the stuff in one place. It spreads it out, so you get relief and just kidding, all in the same unit. So. But this one's short. Yeah, I've pretty much planned this whole unit out already. I'm not sure that if you look at the calendar, it's pretty close to having it all out, unless something crazy happens and I have to be out. So. You never know. So, okay. Are any of these not a composition? You are correct. X plus tangent x is not a composition. Anything else not a composition? We got to know. We're never going to know when to use a chain rule if we don't know what's a composition. Okay. All right. Well, then if we think they're all compositions, let's go. So what about the first one? What would be the inside? X cubed plus 1. And what would be the outside? Square root of x, yeah, taking the square root of that stuff. All right. Listen, y'all have to promise me if I get evaluated in here, you will talk to me. Okay, and you will talk to each other about math. All right, it will be very important. Okay, all right. Because sometimes y'all hurt my heart because you won't talk to me. Okay, let's look at the next one. All right, 3x plus 2 to the 5th. What do you think is the inside? Thank you. 3x plus 2. And what would be the outside? X to the 5th. Okay? So, finding our stuff. All right? So we said x plus tan x, that's just a sum. We could do that with the power rule. Life is good. Okay? Y equals sine of 2x. So it would be your inside. 2x. And your outside. Sine of x. Okay? We're taking the sine of that stuff. So, sine of x. Okay? All right. Next one. 4 sine x cosine x. What's inside? It's okay to be wrong. Oh my gosh, you're killing me. Okay? No. All right. Good try, though. Thanks for trying, Wilmer. I appreciate you. Okay, right? This actually is not a composition. Nothing is inside the other. If there had been parentheses and no x next to the sign, if it had been sine and then parentheses cosine of x, yes, that would have been a composition. But right now, sine x is being what with cosine x? Multiplied. This is a product, okay? We would use the product rule on this one. Okay, it's a product, so it's not a composition, and that's a common mistake, especially with trig functions. You're going to find that a lot of our compositions occur with trig functions. Okay, also they will hide the composition. All right, look at the next one. Y equals sine squared. What does that really mean? How many sine x's do we have? 2. So we could rewrite that as the sine of x, the whole thing squared. Now, does it look like a composition? Sure. Could we have also done it as a product, just like we did a few minutes ago with the warm-up? Sure. Okay, we could have. But it is also a composition. So g of x would be our sine of x. And then f of x would be our stuff that's being squared. Okay, we are squaring the sine. Right? So recognizing the composition is very, very important. All right? Now, what we're going to do is we're going to do several examples that are compositions. Hint, hint. Wink, wink, nudge, nudge. Okay? So we can practice this derivative process and how we would go about it. All right? What our strategy will be. All right? So I'm going to walk you through a couple, and then they're just going to get a lot more interesting as we go. Okay? Because, you know, it's never simple. All right? It has to increase. All right? With creativity and fun and all the algebra. All right? So let's take a look. Here's the first one. Y equals sine to the 5th of x. Anytime I see a trig function with an exponent, I rewrite it. All right? It just gives me a hint, at least when I start, to know that I'm going to do a composition. Okay? So we said a few minutes ago that when we do a composition derivative, we start by taking the derivative of the inside. Okay? So inside is the sine of x. So let's start there. What is the derivative of the sine of x? It's just cosine, yeah? Cos are all negative, all right? It's just the cosine of x, so just the derivative of the inside. Now, what we want to do is do the derivative of the outside. What are we doing to that sine of x? What would be your outside function? X to the 5th. So what's the derivative of something to the 5th? 5 times something to the 4th. Okay, it would be 5 times something to the 4th. And what we put inside of there was our original something. What was originally in there? Sine of x. Okay. Now, there's really not any simplification to that other than they will put your 5 out in front, cosine x, and they'll probably write it as sine 4 and then x. They'll probably drop the parenthesis, all right, on a multiple choice. All right, it's the same thing I have above it in green and purple. All right, but that's probably the more concise answer that you would see on the multiple choice. Okay, so what did we do? We take the derivative of the inside, that's my first part. Okay, cosine. We take the derivative of the outside. The outside is something to the 5th power. So 5 times that something to the 4th. What was that something? It was sine of x. Okay, so we keep the original. Let's look at the next one. Okay, this one's a little tricky too because it's got this fraction. Now, I try to avoid the quotient rule if at all possible. all right? Which means if I have something to a power, can I bring that power up to the numerator? Yeah, okay? I can rewrite this as negative 7 times 2x minus 3. If it's positive 2 in the denominator, what's it going to be in the numerator? What exponent? Negative 2. Okay? That's completely legal. Right? Now that we know chain rule, we can avoid the quotient rule sometimes. Okay? By pulling things to a power up out of the denominator. So, that being the case, let's start our derivative process. Derivative of the inside. So what is the derivative of 2x minus 3? 2. Okay. We're going to multiply it by the derivative of what's happening on the outside. Now, my outside function is negative 7 times something to the negative 2. All right. So think about taking that derivative. Okay. What would you do? I'm just going to put in here because it's my something. Multiply negative. I knew what you're doing. See, I knew your fingers, right? Negative 2 times negative 7 would be what? 14. I'd keep that something. What would I do to the exponent? Minus 1. Negative 2 minus 1 would be negative 3. And I keep that original something that was in there, which is 2x minus 3. Okay. Now, we want to simplify a little bit because we don't like negative exponents. 2 and 14 are just coefficients, so we can multiply those, which would be 28. And I'm going to drop that entire parenthesis to the denominator and make my exponent positive. Okay, so derivative of the inside, derivative of the outside, but keep your original inside. Okay, so try this next one. Y equals cosine x squared minus 1. That's all that one. All right, what's my inside on this one? All right, and so what's the derivative of the inside? All right, cool beans. What's my outside? Cosine, and what's the derivative of cosine? Negative sine, and then what stays on the inside? X squared minus 1, okay? So the only simplification we can really do is that 2x and that negative, so negative 2x sine x squared minus 1. Good. Okay, so it's a product between those two derivatives. Okay. All right, let's look at the next one. Cube root of x squared plus 2, the whole thing squared. All right, well, first of all, that looks terrible. All right, can we rewrite roots as exponents? Sure enough, and we should. Okay, so let's rewrite that. That would be x squared plus 2 to what power? 2/3. Good. Okay. Now, see if you can take the derivative. Y'all have econ today? No. Okay. So let's walk through it. What would be the derivative of the inside? 2x. The derivative of the outside, okay, so something to the 2/3, right? What would your coefficient be? 2/3, and that's something. All right, what exponent would you get? Negative 1/3. 2/3 minus 1 is negative 1/3, and we keep our inside the same, which was x squared plus 2. Okay, now we want to simplify this a little bit. There's not a ton we could do. 2x and 2 would give me 4x. The 3 could come to the bottom, and I could leave that x squared plus 2 to the 1/3 in the bottom, or I could write it as cube root x squared plus 2. Okay, so they're going to always give you a positive exponent, right, in the answer if it's multiple choice. Otherwise, you could leave it if it were in a free response. Okay, so you're starting to get the feel for the inside, the outside, how the rule works. Okay, derivative of the inside, derivative of the outside, keep the inside the same. All right, well, let's just jack it up a little bit. Okay, let's look at this. Okay, sorry, it's all good. I'm good. Okay, here we go. E to the sine x minus 3x. E to the sine x minus 3x. Okay? Woo, fun times. Okay, fun times. So here we go. Derivative of the inside. Okay. Our inside has multiple terms this time, so I'm going to actually put it in a parenthesis. Okay. What would be the derivative of sine x? And derivative of minus 3x? Minus 3, okay? So that's that full first derivative. It's not just one term anymore, it's two, so put it in a parenthesis, okay? Then we want to do the derivative of the outside. Well, the derivative of the outside is e to something. Well, what's the derivative of e to something? E, okay? Derivative of e is e. We keep that inside stuff the same, so sine x minus 3x. There's really no simplification to that. Okay, they probably just wouldn't have the multiplication sign there, or the e would be in the front. Okay, so it's all pretty much the same. Okay, all right, try the one next to it. ln and sine of x. All right, so my inside is what? Yep, and what's the derivative of sine? Cosine. My outside is ln. What's the derivative of ln? 1 over, I would keep it sine. Okay, so this becomes cosine over sine. That should look familiar to you. What is that the same thing as? Cotangent. Yep. Okay, it is cotangent. All right, so putting all those derivatives we learned to good use. Okay, a little bit of trig identity in there, just good stuff, all right? Nothing terrible. All right. All right, try that tangent one. Oh, sorry. You gotta know your derivatives. Yeah. Yeah, you gotta know your trig derivatives for sure. Okay, so let's start inside. All right, so derivative of 3x squared plus 4. Yep, thank you. All right, then our outside is tangent. What's derivative of tangent? Secant squared, and we keep the inside stuff the same. So 3x squared plus 4. And that is actually all you could really do to that. 6x secant squared. 3x squared plus 4. Okay, so there's really not a trig identity for that one. Okay, all right, so let's look at this last one. Okay, on this one. What's my inside? Sine x cosine x. It's a product. Okay, so when I do the derivative of the inside, I have to start with a product rule. Okay, so this is a product. You have to use a product. Oh, for freaking Nukin. You have to use the product rule if it is a product. Okay, so let's walk through that. All right, product rule says we take first times derivative of the second. So derivative of cosine is negative sine. Okay, plus second times derivative of the first, which is that. Okay, so you got to do that product rule for the inside. Okay, so you got to be looking for that. Now we want to do the derivative of the outside. The derivative of the outside is something to the third power. Okay, so if I have n to the third, its derivative would be 3 times that something squared. Well, that something was what we started with, which was sine x cosine x. Okay, now we simplify that a little bit. This is going to give me cosine squared minus sine squared. That does happen to be a trig identity, but I don't think they'll ask you to simplify, okay? The 3 could come out in front, and then sine x cosine x, the whole thing squared. You really can't simplify that to get anything better, okay? I mean, like, it is what it is, right? But you have to recognize that it's a chain in there, right? That it's, well, it's a product to start with. Okay. Now, here's where it gets cray-cray. Sometimes we have multiple compositions within one function, okay? Which means we have to do the chain rule more than once. We have to get all the way to the inside, and then the derivative of the next piece, and then the derivative of the next piece, and then the derivative of the next piece. So it stacks. It's called a multi-link chain, okay? And repeated use of the chain rule is going to happen when I have multiple compositions. Okay, I have multiple compositions, like H of, let's do it this way, F of G of H of X, right? There's just a lot of different inputs, right? Our chocolate process, there were multiple inputs that started, right? And so we would start with H prime of X. It is the most inside function, okay? Times G prime, but keep the H of X, right? Times F prime, but keep the G of H of X. So we keep all the other inside stuff, all right? So I want to walk you through a few of these, all right? Start with the most inside, take the derivative, then take the derivative of the next piece, then take the derivative of the next piece, right? You're just going to work your way inside out, okay? And these sometimes will just make you question your call. Okay, no, I'm just kidding. All right. All right, you'll get good at them. It just takes time. All right. Knowing that we need a multi-link chain. Okay, a multi-link chain. All right. Okay. So here we go. Okay. And the place where you see multi-link chains the most is within trig functions. All right, so just as a heads up, that's where you might want to look, okay? Anytime we have a trig function with something other than just an x inside of it, it's a chain. So that might be something you want to write down. Any trig function that contains anything other than an x is a composition. Okay? Or any trig function to a composition, always. Okay, so any trig function that contains anything other than an x is a composition. So just as a reminder. Okay? And we're going to actually start with my second example instead of my first. All right? Because I think it's a little easier to see the process. Okay? Y'all, my Chihuahua is so rotten. Like, sorry, my hair feels really weird today. It reminds me of his fur. Anyway, squirrel. So my dad made my kitchen table and it has a bench on one side. The Chihuahua has decided now that anytime he wants a cookie, animal cracker, he jumps up on the bench and he sits next to the cookie box. And he looks at it, and then he looks at us. And he looks at it, and he looks at us. And then if we don't respond, he goes, "Burf." Like, he just barks. I'm like, are you talking back? Like, how did I get a dog that sasses? Like, so rotten. He does. Okay, but he and the beagle now are at least friends. Because we come home now and we see them in the yard laid out beside each other. Okay, but the funny part is my beagle loves to lay on the top step on the back porch. Oh, yes. And Goose just jumps over him, like, and jumps in the door, the doggy door. Anyway, okay, so let's look at this one. So y equals, oh, my pen decided to die. Pause. See if it'll work while it charges. If I stand over here. Okay. let's try. Okay. This probably isn't going to be great, but it's going to be the best we can do. Just kidding. Nothing's going to work. Okay. Okay, so that worked. Okay, so I'm going to write really big. It's okay. All right. So I can get enough juice in the other thing. So I'm going to rewrite this as the sine of 4t to what power? Because it's a square root. 1/2. Okay. Now, I know this is a multi-link chain because 4t is inside as well. Okay. So 4t is inside as well. So let's start with the most inside function. So y prime, what is going to be the derivative of just 4t? 4. Okay. All right. So we got that. Now, we're going to multiply that by the next most inside thing, which is sine. What's the derivative of sine? Cosine. And I'm going to keep what was already in there, which was the 4t. Okay? I don't know why I just tried to write a negative. Okay, that's a times, pretend. All right, then the last thing we want to do is look at the last thing that we had, which was something to the 1/2. So that derivative is going to be 1/2. My something is going to go to what power? Negative 1/2. What was the something that was inside of that? Well, it was the sine of 4t. Okay, so I keep the entire inside. Let's take a second to dissect the pieces. All right. We started with the most inside piece, which was the 4t, okay? Derivative of the 4t gave me the 4, right? Then the next inside piece was sine. Derivative of sine is cosine. I kept what was already there, okay? Then we do the last piece, which was something to the 1/2. So 1/2 goes to negative 1/2. I keep everything that was there, all right? So do you see what I mean by multi-link? You've got to get all the way to the inside and work your way back out. Okay, with your derivatives. Now, really not a lot of simplification there. 4 and a 1/2 I could put together. What's that going to give me? 2 cosine 4t. And then that would be over the square root of sine 4t. Because that's to the negative 1/2. Okay, so there's really not a lot simplification-wise we can do besides that. All right, let's look at the one before it, because at this time I think the composition is a little more complicated to see. Okay, so I've got tangent of 5 minus sine 2t. All right, well, I see I've got tangent as an outside function, 5 minus sine 2t is an inside function. Where's that third composition? Inside of sine. Okay, so we're going to start there. Okay, so my innermost composition, what's going to be the derivative of 2t? Two. Okay. The next most inside thing, all right, is that sine. Okay, is that sine. And so what would be, well, and the reason it's just that sine is because what's the derivative of 5? It's just nothing, right? So what's going to be the derivative of negative sine? Negative cosine. And I keep the 2t. Okay? The next most thing we have is tangent of all that. What's the derivative of tangent? Secant squared. Okay? It's secant squared. And I keep all the inside stuff. So 5 minus sine 2t. All right? If we simplify all of that, really all we're going to get is that negative 2 cosine 2t secant squared 5 minus sine 2t. Okay. All right. Last thing I want to do, I think, 2 things. Okay. We really have to be, that looks so terrible over there. Sorry. Okay. It's like a psychopath came in and did that problem. Serial killer. Okay. Do y'all watch those serial killer documentaries on Netflix? Do you? Okay. I can't watch those because they freak me out. But anyway. They said the new monster one was really good, but disturbing. Anyway. Okay. So it tells me just to differentiate, but notice it says to beware of parentheses and trig functions, and that's important. All right, let's look at the first one. Cosine of 3x squared. Composition, not composition. Composition. Okay, this would be chain rule. Okay, this one would be chain rule because inside is that 3x squared. Okay, so that one would be chain rule. So y prime, derivative of the inside would be 6x. Derivative of the outside will be negative sine of that 3x squared. So negative 6x sine 3x squared. Okay, so that one was a composition. Okay. I love the next one. Okay, I love the next one. Parentheses are important. Okay, because is that x inside the cosine? No. Cosine of 3 is a number, all right? That's a coefficient. This is just general power rule, okay? Because cosine of 3 is a coefficient. So if that's the case, when I do power rule, x to the second would be 2 times the coefficient that was already there times x to 1 power less, so just plain x. So 2 cosine of 3, again, just a coefficient, times x. So that one's tricky, right? That cosine of 3 is a number, not a variable. All right, let's look at the next one. So same values, I'm just rearranging where the parentheses are, okay? So the next one, cosine of 3x, just the 3x is squared, okay? Cosine of 3x, just the inside is squared. Chain rule or not chain rule? It is chain rule, okay? And in fact, it's a multi-link chain, all right? It's a multi-link chain. What's our most inside piece? 3x, okay? The most inside piece is that 3x. So what's the derivative of 3x? It's 3, okay? The next most inside piece is that stuff squared, okay? So to do that derivative, it would be 2 times that stuff to 1 less power, okay? And I would keep the 3x. And then what's my outermost function? Cosine, which would be negative sine, keep all the other stuff. Right? So again, putting together things that we can, negative 1, 3, and 2 would be negative 6. 3x is to the first, so we could combine that as well. And then sine of 3x, the whole thing squared, or negative 18x sine of 3x squared. Okay. All right, once again, that last one, we put parentheses in a little different place. This time cosine is squared, so I'm going to actually write that as the cosine of 3x, the whole thing squared. Is it chain rule? Yep. Single chain or multiple chain? Multiple. Got multiple things inside there. Okay. Who is the innermost function? 3x. So y prime, what's the derivative of 3x? 3. Okay? My next innermost function is cosine. Okay, so derivative of cosine is going to be negative sine, and I keep the 3x. My outermost function is something squared. So times 2 times something, reduce it to the first power. Okay, the something is all that junk that was already there. Right? So my final answer, 3 times a negative 1 times a 2, so a negative 6 sine 3x cosine 3x. Okay? Very different derivatives based on where the parentheses are. Would you agree? Yeah. Okay? A lot going on right there. Okay. All right. Number 11. That's a new word. Made that up over the break. Number 11. All right. They give you a function. They ask you to find the derivative. It's multiple choice. Which one's correct? All right. Take a second and play with that one. It's going to be the last thing we do. All right, which one do you think? Sample 2. All right, I got to vote for 2. Everybody else got to vote? Another one for 2. Saw some head nods. Okay, well, let's walk through it. So, definitely a chain rule. What's my innermost function? All right, it's 2x. So, derivative of 2x would be 2. What's the derivative of secant? Secant tan, okay, of whatever was in there, okay? So, you have to have them both, okay? They both get a inside, all right? So, secant tan. So, that's why it has to be 3, all right? So, I'm glad y'all picked 2 because that helps me to make that point, okay? Yeah, so we have to include it. All right, so here you go. On page 165, you've got to practice the chain rule. All right, 1, 3, 5, 7, 13, 17, 19, 23, 25, and 27. Okay, you do have a wrap up. It's on your Google Classroom, so let's be sure and get that done before we leave today. So I think this one's just asking you like to type out. It's not actually math. And how would you know something's a composition? Tomorrow, we're going to look at some AP level problems. So some free response questions that involve the chain rule, some multiple choice questions. Like I said, it's a little bit shorter of a lesson, but we do have a, lockdown drill tomorrow, okay? So we'll move quickly and quietly and do all the things we're supposed to do, and then we'll get back at it, okay? All right, be sure and pick up your trash off your table if you don't mind, and we'll wrap it up.